The ancient pyramids of Egypt are a commonplace global landmark for all human beings, and as mysterious and awing as the recorded 120 pyramids of Egypt are, they are but a small fraction of the currently uncountable pyramids and pyramidal structures across planet Earth. With pyramids publicly recorded in places like the rest of northern Africa, Austria, France, and the astronomical amount that rest in Mesoamerica, as well India, China, and even an ancient city underwater involving pyramidal architecture off the shores of Japan. However, there are many researchers and eyewitnesses who claim that the public knows of only a fraction of the pyramids on the globe, and that these are being actively hidden from the masses. In places like Bosnia, China, the wilderness of Ontario, or anywhere depending on who your sources are, one might expect to find some surprising hidden structures, like a pyramid beneath the water made of glass in the Bermuda Triangle, Alaska's Dark Pyramid, or pyramids caked in snow, hidden in the mountains, which is quite a tantalizing claim with both Charles Hapgood's and Graham Hancock's research, showing that there have been some seriously underreported fossils of vegetation in Antarctica. While many think these structures are merely speculative, the search for a giant pyramid beneath ice sheets suggests that these structures are very real, just extremely well hidden, hinting at an ancient civilization frozen in time. Join us as we embark on an extraordinary expedition to uncover the hidden mysteries buried beneath 4,600 feet of ice in Antarctica. Antarctica is the epitome of the unknown. Nearly 98% of the ground is covered by an ice sheet up to 3 miles thick, a mountain as towering as Japan's Mount Fuji at 12,400 feet would not even break the surface. Temperatures regularly fall below -50 degrees Fahrenheit, with winds of up to 200 miles an hour. Its extreme conditions and inaccessible terrain have made it a challenging subject for study, preserving its secrets under a thick blanket of ice that has not melted for millions of years. This isolation has spurred countless theories about what lies beneath the surface, from ancient artifacts of lost civilizations to evidence of alien visitation and hidden military installations. Suspicion aroused more and more when the Antarctic Treaty, which designates Antarctica as a scientific preserve, banned military activity on the continent and promoted international cooperation in scientific research, signed in 1959. While the treaty is hailed as a landmark of peace and collaboration, it also restricts unauthorized travel and exploration, fueling conspiracy theories about what governments might be hiding. The stringent control over access to certain areas has led some to speculate about secret bases, covert research into alien technologies, or archaeological digs uncovering civilizations that could rewrite the history of human development. Thus, despite the challenges posed by the icy wilderness, intrepid explorers continue to push the boundaries of human knowledge, venturing beyond the ice wall with a desire to unravel the mysteries that lie hidden beyond the icy veil. And what they found was astonishing. Researchers have found fossils and remnants of ancient life forms that once thrived when Antarctica was part of the supercontinent Gondwana and enjoyed a much warmer climate. Around 574 million years ago, when animal life first began on Earth, initially in the marine environment, Antarctica lay along what is now Australia's southern margin. Australia and Antarctica were rotated 90 degrees from where they are today. The equator ran through both continents. About 400 million years ago, Gondwana moved dramatically, and Antarctica took its place over the South Pole. The carbon dioxide content of the atmosphere was much higher than it is now. As the oxygen content grew, it reached the stratosphere and was converted to ozone. The ozone provided protection from ultraviolet rays, and life spread from the ocean to the land. About 130 million years ago, Gondwana began to disintegrate. India, South America, and Africa broke away. The links between Australia and Antarctica remained until about 55 million years ago. Australia began moving north quickly, and Antarctica was isolated for the first time since animals evolved. About 30 million years ago, the Southern Ocean began to circulate around the southern world, and the modern Antarctic environment evolved. Fossil from now extinct Glossopteris trees are well preserved in Antarctica. The concept of Gondwana was first proposed to explain the widespread distribution of glacial rocks and Glossopteris. When Robert Falcon Scott and his men were found dead in their tent on the way back from the South Pole, specimens of Glossopteris from the Beardmore Glacier region were found with them. While they had jettisoned almost everything else on the way back, they recognized the importance of the Glossopteris and refused to leave the specimens behind. These specimens are around 280 to 300 million years old. Many elements that still exist in some southern hemisphere cold temperate rainforests, such as in Tasmania, New Zealand, and southern South America, used to be present in Antarctica. It is clear that these elements continued in Antarctica until about 35 million years ago, but there are other tantalizing pieces of evidence to suggest that it continued until much more recently. Abundant remains of the southern beach Nothofagus have been found only 400 kilometers from the South Pole. Dinosaurs lived in Antarctica and are well known from the northern tip of the Antarctic Peninsula, although few have been described formally. They include ankylosaurs, the armored dinosaurs, mosasaurs, and plesiosaurs, both marine reptilian groups. Seymour Island, just off the Antarctic Peninsula, is one of the most important fossil sites on Earth. It contains a bewildering array of different fossils, representing many different environments. It also includes one of the very few uninterrupted sections across the Cretaceous-Tertiary boundary, the time when dinosaurs and many other life forms died out, probably due to meteorite or asteroid impact. Marine plain in the Vestfold Hills has a great diversity of fossils from 4.5 to 4.1 million years ago. The best known are the fossil dolphins and whales. About 5 or 6 species are known. The dolphins are very different from modern dolphins. They consist of 2 species, one about 4.5 meter long and the other about 8 to 9 mm long. They are unusual as they lack teeth. They may have located squid by echolocation and eaten them by sucking them into their very long, slim jaws. The dolphins are quite common and occur as almost complete skeletons. It is as if they died and sank gently into the mud. It is clear that a major extinction event occurred around 2 to 3 million years ago. This may be part of a global extinction event. The cause is debated, but one strong contributor was probably the closure of the Isthmus of Panama, which caused the flow of water from the Atlantic to Pacific Ocean to stop, causing the Gulf Stream and Northern Hemisphere glaciation to begin. Another contributor may have been the Himalayas, which were growing at the time and influenced the circulation of the atmosphere in the Northern Hemisphere. However, it's not just ancient life forms in Antarctica that spark interest. There are theories that suggest that Antarctica might be hiding evidence of lost, ancient civilizations. The continent's ice sheets, some of which are miles thick, have the potential to preserve whatever lies beneath them, much like a giant cold time capsule. Perhaps the oldest and most frequently cited piece of evidence for the possibility of an ancient civilization in Antarctica is the spectacular 1513 Peary Race world map dating to the European Great Age of Discovery. It is one of the best-known early maps to depict the Americas, presenting a cartographic record of the oceanic voyages, expeditions, and discoveries of Christopher Columbus and other early explorers in the last decade of the 15th century. The map is, in fact, a fabulous type of portolan sailing chart created in the early 16th century by Ottoman admiral of the fleet, geographer, and cartographer Peary Race. It was found in the library of Topkapi Palace in Istanbul in 1929, when the palace was being converted to a museum. The map is drawn on parchment made from gazelle skin, and only a portion of the original is known to have survived. The surviving map fragment measures 35 by 24 inches. This is thought to be approximately 1/3 of the original. The map is remarkable in a number of ways. not the least for having been created at a time when correct topographic positioning of recently discovered regions of the world was technically exceedingly challenging. The well-known Old World had been explored and mapped for centuries, and the mapping of it was quite accurate at the time Piri Reis was creating this map. However, the New World was new and unexplored, and drawing a map based on the few documented and recorded voyages to it required thorough research of all known sources. Though created centuries before the advent of geolocation technology, the map presents new topographical information, much of which is surprisingly accurate. The map illustrates a relatively accurate coastline of South America. It also hints at the presence of a landmass where Antarctica is, albeit one with no ice. The outline of the supposed Antarctic depiction more closely resembles the physical land of the Antarctic continent than it does the ice pack, which stretches out into the ocean beyond the land. So, if Piri Reis did manage to make it that far south, he should have drawn the outline of Antarctic ice, not the land, unless, of course, he had some special knowledge that others lacked. In addition to an unfrozen Antarctica, the map features other details that have led some minds to speculate that Piri Reis's cartographic knowledge must have been created by some unknown but highly advanced civilization who explored the world long before our recorded history. These earlier people must have visited and possibly inhabited Antarctica before it froze over. Proof that Antarctica was once populated. The most compelling evidence for a hidden history in Antarctica comes from giant structures that appear to be man-made. Deep amid the icy expanse, a series of massive stone pyramids had been found. Their ancient forms stand in stark contrast to their desolate surroundings. The revelation sent shockwaves through the scientific community and ignited the imagination of the world. As the researchers ventured closer, they discovered that the pyramids were not mere stone structures. Advanced technology lay hidden within the depths of the ancient monuments. Massive entrances leading into the mountainside and geometrically precise formations have been documented, challenging the natural origins of these features. Some researchers suggest these could be the remnants of an ancient civilization, predating known history and possibly connected to the mythos of Atlantis or other legendary lands spoken of in ancient texts. Accounts of discovered structures beneath the ice, complete with intricate inscriptions and warm interiors, unaffected by the external freezing temperatures, suggest the presence of advanced technology or knowledge. Testimonies from military personnel, including a Navy SEAL's description of a vast illuminated chamber with hieroglyphic-like carvings, point to the existence of an ancient civilization or alien presence that has mastered technologies far beyond our current capabilities. In other words, this staggering discovery challenged everything about the conventional narrative of human history. Theories about extraterrestrial influence on Earth's ancient civilizations had long been the stuff of speculation. However, now, concrete evidence stood before the world. News of the Antarctic pyramids spread like wildfire across the globe, captivating the imagination of people from all walks of life. Governments, scientists, and conspiracy theorists alike grappled with the implications. The realization that ancient extraterrestrial beings had visited Earth and left behind a technological legacy raised profound questions about humanity's place in the cosmos. As the world grappled with the revelation, nations scrambled to establish a presence in Antarctica. Scientific teams and military units flocked to the frozen continent. All were eager to study the pyramids and unlock the mysteries they held. Tensions rose as geopolitical rivalries clashed against the backdrop of an enigmatic alien legacy. Their research became a race against time as they sought to decipher the alien technology within the pyramids. The crystals, pulsating with an otherworldly energy, hinted at untapped knowledge and capabilities far beyond human understanding. All of this is really worth waiting for. Either way, Antarctic science stands as a beacon of discovery, offering profound insights into the complex dynamics shaping our planet. Over the decades, Research conducted in Antarctica has not only expanded our knowledge, but has fundamentally altered our understanding of Earth's past, present, and future. At the heart of Antarctic science lies the study of climate change. Antarctica, with its vast ice sheets and frigid temperatures, serves as a sentinel for global climate trends. Through meticulous analysis of ice cores, sediment samples, and atmospheric data, scientists have reconstructed Earth's climatic history with unprecedented precision. These records reveal patterns of natural climate variability spanning millennia, providing crucial context for understanding contemporary climate change. One of the most compelling revelations from Antarctic research is the unequivocal evidence of human-induced climate change. By comparing historical climate data with modern observations, scientists have documented unprecedented shifts in temperature, precipitation patterns, and ice melt rates. The rapid retreat of glaciers and ice shelves, once thought to be immutable, underscores the urgency of mitigating greenhouse gas emissions to avoid catastrophic consequences for coastal communities worldwide. Antarctic science has also revolutionized our understanding of sea level rise. The continent's vast ice sheets hold enough fresh water to raise global sea levels by meters, making Antarctica a focal point for studying ice dynamics. Satellite observations, coupled with field research and computer modeling, have revealed the accelerating loss of ice mass from Antarctica's glaciers and ice shelves. These findings have profound implications for millions of people living in low-lying coastal areas, highlighting the need for proactive adaptation strategies to mitigate the impacts of rising seas. Beyond its role in climate science, Antarctica is a hotbed of biodiversity and ecological research. Despite its harsh conditions, the continent teems with life, from resilient microorganisms to iconic penguin colonies. By studying Antarctic ecosystems, scientists gain valuable insights into the adaptability of life in extreme environments. This research not only enhances our understanding of polar ecosystems, but also sheds light on the broader principles governing biodiversity and ecosystem resilience in the face of environmental change. Antarctic science extends far beyond Earth, offering valuable lessons for space exploration and astrobiology. The extreme conditions found in Antarctica serve as an analog for studying the potential for life on other planets and moons in our solar system. From subglacial lakes to high-altitude deserts, Antarctic environments provide valuable opportunities to test instruments, techniques, and theories relevant to astrobiological research. By unraveling the secrets of life in Antarctica, scientists gain critical insights into the fundamental principles underlying the search for extraterrestrial life. As a worth note, in this century, astrobiologists are so optimistic about finding life beyond Earth. That, basically, depends on three things. The first one is extremophiles. The more we learn about microorganisms on Earth, the more we're surprised by the incredible adaptability of life. The hardiest life forms are known as extremophiles, and they've been discovered surviving in some very inhospitable environments. They've been found in boiling hot hydrothermal vents, beneath freezing cold glaciers, in acidic pools of volcanic water, deep under Earth's crust, and even in high radiation zones. Extremophiles teach astrobiologists about the outer limits for life and what sort of extraterrestrial environments might be habitable. The second one is exoplanets. Before 1992, the only planets we knew existed in the entire galaxy were the ones in our solar system. Since then, our telescopes have discovered almost 5,400 worlds orbiting other stars, so-called extrasolar planets or exoplanets. Most of the first exoplanets detected were bloated gas giants orbiting exceedingly closely to their suns, not the sort of world we believe could harbor life, but these were just the easiest to detect. We've since discovered smaller and smaller exoplanets orbiting further from their stars. For astrobiology, the most exciting exoplanets are small, rocky, Earth-like ones orbiting the right distance from their stars so that their surface temperatures allow oceans of liquid water. These are potentially habitable worlds, and would offer the best chances for extraterrestrial life. Future space-based telescopes would hopefully be able to detect signs of life, called biosignatures, in their atmosphere, such as the presence of oxygen gas released by photosynthesis. And the last one is robotic exploration of the solar system. Over recent decades, advances in robotics and the sophistication of scientific instruments have made our space probes more and more capable. There has been a fleet of orbiter, lander, and rover missions launched to Mars, as well as probes sent to explore the outer planets, Jupiter and Saturn, and their families of moons. Every time we visit another world, we learn an enormous amount about its environment, active processes, and its history, and invariably spark a whole slew of new questions to answer. All life on Earth needs liquid water to survive. It's very good at dissolving chemicals to support the reactions of biochemistry. Life here is also organic, built from complex molecules based on carbon atoms. It makes most sense for astrobiology to search for the sort of life we know is possible and we have a good idea how to detect. But could extraterrestrial life be based on a completely different kind of chemistry? The element silicon sits just below carbon on the periodic table, and so, in many ways, its chemistry is similar. But compared to carbon, silicon isn't nearly as good at forming stable chemical bonds and large, complex molecules. However, alien life could be based on solvents other than liquid water, perhaps ammonia. But where are we going to find that life? It was once thought the solar system was probably a barren wasteland apart from Earth. Rocky neighbors were too dry and cold like Mars, or too hot and hellish like Venus. The other planets were gas giants, and life on those worlds or their satellite moons was basically inconceivable. Earth seemed to be a miracle of a miracle. But life isn't that simple. We now know that life on Earth is able to thrive in even the harshest, most brutal environments, in super cold and super dry conditions, depths of unimaginable pressures, and without the need to use sunlight as a source of energy. At the same time, our cursory understanding of these obscure worlds has expanded tremendously. Our rocky neighbors of Venus and Mars may have once been temperate and Earth-like, and some of the life might have lingered on after these planets' climates took a turn for the worse. Several of the icy moons that hang around Jupiter and Saturn might have underground oceans that could sustain life. A couple may even have atmospheres, and still other places that seem to be too exotic for life continue to surprise us. Unlike the myriad of new exoplanets we're identifying every year, when it comes to worlds in the solar system, we have the ability to send probes to these places and study them directly. As David Catling, an astrobiologist at the University of Washington, said, "We can measure things that would be impossible to measure with telescopes. They could study things up close, maybe fly into the atmosphere or land on the surface, and perhaps one day even bring back samples that could reveal whether these planets and moons are home to materials or fossils that are evidence of life, or perhaps life itself. Here are the 5 best places in the solar system to look for extraterrestrial life, subjectively ranked by yours truly, for how likely we are to find life, and how easy it would be to find it if it's there." 8. Io. Boasting over 400 active volcanoes, Io is the most geologically active world in the solar system. All of that activity is thought to be caused by tidal heating created as Io's interior is gravitationally pulled between Jupiter and the other Jovian moons. The volcanism results in a huge coating of sulfur and sulfur dioxide frost. Yes, that's a thing. Across the globe, along with a super-thin sulfur dioxide atmosphere. There might even be a subsurface ocean on Io, but it would be made of magma, not water. Life on Io is very unlikely. But all that heat is a bit of an encouraging sign. There may be locations on the surface or underground that aren't overwhelmed by the volcanic activity. More temperate places where hardy forms of life have found a way to survive. We wouldn't be able to study those spots directly, but a probe might be able to find evidence of life if it gets lucky. That's easier said than done. The best chance of studying Io is through a proposed NASA mission called Io Volcano Observer, which, if approved, would launch in 2029 and do 10 flybys of Io Box 7. Callisto. Callisto's claim to fame is that it has the oldest surface in the solar system. That doesn't really mean much in terms of habitability, though. Where Callisto shines for our purposes is that it's another moon that's thought to have a vast subsurface ocean, 155 miles underground. It also retains a thin atmosphere of hydrogen, carbon dioxide, and oxygen, which is more diverse and Earth-like than most of the other solar system moons that could be habitable. Still, Callisto's chances of hosting life are not as favorable as other worlds, namely because it's still pretty damn cold. For now, our best chance of really exploring it is the European Space Agency's Jupiter Icy Moon Explorer, or JUICE for short. Launched in 2023 with the mission to explore 3 of Jupiter's moons, JUICE will make several close flybys of Callisto during its mission. 6. Ganymede. The largest moon to orbit Jupiter, and simply the largest moon in the solar system, is covered up in an icy shell. But underneath that surface is home to a global underground saltwater ocean that might contain more water than all of Earth's own oceans combined. Naturally, all that water has scientists hopeful that some kind of life could exist on the moon. The moon even has a very thin oxygen atmosphere. Nothing to write home about, but it's something neat. And Ganymede has something else no other moon in the solar system has: a magnetic field. A magnetic field is critical for protecting worlds from harmful radiation spewed by the sun. But Ganymede isn't perfect. A subsurface ocean is difficult to study, so if there's life on the planet, we're going to have a difficult time finding it. And so far, there has not yet been a dedicated mission to study Ganymede, although the JUICE will be the most in-depth investigation of Ganymede when it enters the moon's orbit in 2034. It may have an opportunity to peer down at the surface and study the interior using radar and clue scientists into Ganymede's potential habitability. 5. Venus. Here at the halfway point is where we start to get into the good stuff. Venus has surface temperatures that are hot enough to melt lead and surface pressures that are more than 80 times as harsh as what we experience on Earth. And yet, maybe Venus is home to life. Those prospects ignited last year when researchers detected phosphine gas in very thick Venusian atmosphere. On Earth, phosphine is primarily produced naturally by life in oxygen-poor ecosystems, which raises the possibility that there might be life on Venus responsible for producing it as well. And the most likely scenario would be microbial life that's hanging within the clouds, airborne life basically. Now, the phosphine detections have come under scrutiny, and the idea of airborne life is certainly not something all scientists can get behind. But this, and other work that's explored Venus's history of water, have renewed a lot of great interest into the idea that Venus may have once been habitable, and might still be. The new Da Vinci Plus and Veritas missions that NASA will launch late this decade won't find life, but they will get us closer to answering that question more concretely. 4. Enceladus. Saturn's 6th largest moon is completely covered in clean ice, making it one of the most reflective bodies in the solar system. Its surface is ice cold, but there's quite a bit of activity going on underneath. The moon ejects plumes that contain a myriad of different compounds, including salt water, ammonia, and organic molecules like methane and propane. Enceladus is thought to have a global salty ocean, and NASA's found evidence of hydrothermal activity deep underground, which could very well provide a source of heat that's necessary to give life a chance to evolve and thrive. In some ways, Enceladus ought to be higher up my list than Titan, were it not for the fact that there just simply isn't any mission on the books right now to study it. Plenty of proposals have been debated for the last several years, including several under NASA. All are geared toward an astrobiological investigation that would look more closely for signs that Enceladus is habitable to life. While digging underground into the ocean would be the most surefire way to determine whether the moon is home to life, we might also catch a lucky break and be able to detect biosignatures that have been spewed up by the moon's cryovolcanoes, but not for a long time. 3. Titan. Titan, Saturn's largest moon, is another world that sets itself apart from the rest of the solar system. It has one of the most robust atmospheres for a rocky world in the solar system outside of Earth and Venus. It's teeming with different bodies of liquid, lakes, rivers, and seas. But they're not made of water. They're made of methane and other hydrocarbons. Titan is extremely rich in organic materials, so it's already rich in the raw materials needed for life. And it may also have a subsurface ocean of water as well, though this will need to be verified. Scientists have just the mission lined up, the NASA Dragonfly mission, which will send a drone helicopter to explore Titan's atmosphere directly and give us a much-needed sense of exactly how developed its prebiotic chemistry runs. That mission is planned to be launched in July 2028 and arrive at Titan in 2034. 2. Europa. Jupiter's moon has an icy shell that's 10 to 15 miles thick, covering up a huge subsurface ocean that's heated up by tidal forces. That heating is thought to help create an internal circulation system that keeps waters moving and replenishes the icy surface on a regular basis. This means the ocean floor is interacting with the surface, which means if we want to determine whether life exists in those subsurface oceans, we may not necessarily need to go all the way down there. Scientists have found deposits of clay like minerals associated with organic materials on Europa, and it's suspected that radiation hitting the icy surface could result in oxygen that might find its way into the subsurface oceans and be used by emerging life. All the ingredients for life are potentially here. Luckily, we're set to study Europa in great detail. JUICE will make 2 flybys of Europa during its time in the Jovian system. But the marquee mission on the books is Europa Clipper, a spacecraft that would conduct low-altitude flights that would attempt to study and characterize the surface and investigate the subsurface environment as best it can. Clipper launches in 2024 and will reach Europa in 2030. Or Mars. Mars takes the top spot for several reasons. We know it was once habitable billions of years ago, when it had lakes and rivers of liquid water on its surface. We know it had a robust atmosphere back then to keep things warm and comfy. And we currently have a rover on the surface, Perseverance, whose express goal is to look for signs of ancient life. It will even secure samples that will one day bring back to Earth to study in the lab. So what does that have to do with finding current life? Well, if there are signs of ancient life, it's possible life on Mars still exists. Probably not on the surface, but maybe underground. There have already been a few big studies that have used radar observations to show that reservoirs of liquid water probably exist a couple kilometers below the surface. We've found bacteria on Earth surviving in similar conditions, so it's entirely possible something is living in those parts of Mars as well. Getting down there will be insanely difficult. But if we have reason to believe something is lurking in these reservoirs, it'll be all hands on deck to figure out how we can get there and see for ourselves. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.